Hello and welcome to Spectacular Science, the Science of Color. This video is all about the science of color and light and why we see things the way that we do. So to start out, I'm going to ask my example students here, have you ever painted before? Raise your hand if you've painted before. Alright, have you ever mixed your paints to get a specific color? Alright, so then you're going to nail this one. If I mix this red and this blue together, what color am I going to get?
Purple.
Purple. Alright, let's start with, we'll put in our red here. Let's see if you're right. We'll put in our blue. I've always noticed it's more red than blue to get purple. You kind of see the purple color there?
Mm-hmm.
Yeah?
You may want to put in more blue.
A little more blue?
Looks red.
There, how's that look?
A bit more, like the rest of it.
Pretty good? Alright, so if we do red and blue together, then we get purple. Now if I add this green in, what color do you think it's going to be?
Black.
Yeah, it would be black, or maybe a dark brown. But the more I add in, the darker and darker it gets, right?
Mm-hmm.
Okay. And is that pretty consistent with what you've seen when you painted? The more colors you add, the darker it gets, the darker brown, the closer to black it gets. Is that about what happens when you paint? Yeah. Okay. So if you've noticed that and you've seen that before with mixing your colors, now I'm gonna ask you a question. I have these 3 flashlights and they're covered with red, blue, and green transparencies, the same colors we have here. And based on what we saw with the paint, if we were to mix these 3 colors of light together, what color do you think we would get?
Black.
Yeah, black, dark brown, same type of thing. You get a darker color. Well, the reality is actually very different, and it's really cool to see that work. So, would you mind hitting the light for me, please? So we're going to see what happens when we mix these colors of light. Let me kind of make this a little more diffuse for you. Okay, you want to take the green one? All right, you want to take red for me? And I'll be blue. And you'll see here, as we put these 3 colors together, and move that back just a little bit, you can see that on the contrary, instead of getting black, in the center there where they're all mixing together, you get white. And you can see that especially as I take one of the colors away. Here we have just a really bright red. And then the more colors that we add, the lighter, the more white the color ends up on the inside. So it's exactly the opposite of what we saw with our paints. Go ahead and take a glaze for me. Not what you would expect, was it? No. So to understand why that is, first we have to understand something about light. The light that you see around you, the light that comes out of your light bulbs or from the sun or from flashlights, is a white light. But in reality, it's actually made up of a bunch of different colors, the whole rainbow of colors. Now if you could pass that light through a prism, through a piece of glass that's just the right shape, then you could actually split up that white light into all the rainbow of colors that light is made up of. Have you ever seen something like this hanging from a window?
Mm-hmm.
What do you see on the ground and around it where the light goes through it?
Rainbow.
You see rainbows. It's not changing the light. All it's doing is taking that light and splitting it up into the rainbow of colors that make up light. Now when this light hits an object, any object, some of that light is absorbed or taken in, and some of that light is bounced back off. So for example, we have a red apple here. Now the light comes and hits the apple, and the orange and the yellow and the green and the blue, that's all absorbed into the apple. But the red light is reflected or bounced back off and goes right into your eye. And that's why the apple looks red, because that's the color that's reflected or bounced back off. So now that we understand that, now we can understand a little bit better what happened when we mixed our light and when we mixed our paint. So our lights here, these are actually called the primary colors of light, red, blue, and green. These colors can be mixed to make any color that you see, as long as you have these 3 main colors. Now these lights are pure energy, so the more colors you add in, the lighter it gets. The way to remember it is the more light you add, the lighter the color. So if you get red and green light together, you get a lighter color, you get yellow. If you add blue and green together, you get a lighter color, kind of this cyan light blue color. So the more light you add, the lighter your color, until if you add the three together, you actually end up with white. Now, your paint works very differently. With paint, you are using pigment to get your color. Pigment is what you use to make things look a specific color. It's made to reflect a certain wavelength of light and to absorb all the others. And so as you add more colors together, when you put and the primary colors for them are actually yellow, cyan, and magenta. Those are the three colors that they mix. That's why we didn't get quite exactly black here. Red, blue, and green are not the primary colors for pigment. It's yellow, cyan, and magenta. Those are the ones that when mixed together get black. Now the red, the blue, and the green are pretty close, and they're the primary colors for light, and so we can kind of use them to approximate it. But you'll get a much more black if you use these exact colors. Yes?
I think it works because when you mix these three colors, not all together, you mix magenta and yellow, you get the red. You mix the magenta and the
Cyan.
you get this blue, and the cyan and the yellow, you get the green.
Yeah, and then those three colors mix together, and you get the red.
I think that's why it works.
Yeah, it works. They're kind of all connected. They're all related because they're all absorbing certain wavelengths of light and reflecting other wavelengths of light.
And you get the black.
And you get the black.
Mhm.
I'm sorry. When you add them together and you put them together, they absorb more and more and more of the light. So when you're adding light together, you're adding more light, you're adding more pure energy, and you get white. But when you're doing the pigments, well, now what you're doing is you're adding more things that take more light, absorb more light, and they reflect back less and less. And so eventually you see black. And when you mix the colors together, you always get something darker because it's always pulling in more light. All right, so now this explains the science behind color, but then it's fun to let the kids have some time experimenting. So here you go. And trying different colors. And in addition to experimenting with pigments, they can compare and contrast that with experimenting with little lights. There's a couple of different ways you can do that. You can use the Christmas lights, and you can do the same thing. Where's my primary colors? Red, green, and blue. Now the red one, this one is a little bit less intense. And that's one of the difficulty when we're working with the lights, is that the intensity varies. And so you have to get it just the right mix of lights to get to the white. Otherwise one overpowers the other and you see that color more. But there, right in the middle, you can see the white. See that? Should we try for one of the colors? Let's see. We have red and green makes yellow. So let's try for that one. If I can get them, there we go. You can get them just the right space. You can really see the yellow in there. You can actually do the same thing with your finger lights. But you gotta get them just the right distance and intensity. It takes a little bit of playing with it. But there you go. You see the yellow there?
Yeah, I see.
Let's see if you can try it. And then one final fun activity is to use your prisms. Now I don't happen to have on hand any of your standard shaped prisms, but these will work also. And you'll notice that some of the light just passes straight through, so you mostly see just white light. Would you mind hitting the lights for me? Okay. But if you can play with a little, get the right angle, there you can see some of the rainbows. So there you can see the light split up in its colors. See that?
Wow.
And that's kind of fun to play with. You want to try it? There you go. It's got a really long rope on that, so you might want to just hold the actual prism. There you go. There you are.
That's really cool.
All right, and that concludes our Science of Color video. Thanks for joining us.